To accurately determine the amperage of the cooktop, you need to divide the wattage by the voltage. The cooktop in this situation has a rating of 7.7 kilowatts. Since 1 kilowatt is equal to 1000 watts, 7.7 kilowatts translates to 7700 watts. The voltage supplied to the cooktop is 240 volts. To calculate the amperage, the formula is as follows: amperage equals wattage divided by voltage. Plugging in the values, you get 7700 watts divided by 240 volts, which equals 32.8 amps. This calculated value of 32.8 amps represents the amount of current the cooktop is expected to draw under normal operating conditions. The 20 amp double pole breaker currently installed is inadequate for this cooktop because it is rated for a current draw significantly lower than the cooktop's calculated amperage. A breaker's purpose is to protect the circuit and prevent overheating and potential fire hazards by interrupting the current flow when it exceeds the breaker's rating. Using an undersized breaker, such as a 20 amp breaker for a 32.8 amp load, poses a safety risk. The breaker is likely to trip frequently, which can be inconvenient, and more importantly, it indicates that the circuit is being overloaded. Continuous overloading can damage the wiring and increase the risk of a fire. The minimum required breaker size for a 7.7 kilowatt cooktop operating at 240 volts needs to be at least 30 amps. This is because standard breaker sizes typically available are 15 amps, 20 amps, 25 amps, 30 amps, 35 amps, 40 amps, and so on. The calculated amperage of 32.8 amps exceeds the 30 amp rating but is less than the 35 amp rating. Choosing the next highest standard breaker size would result in a 35 amp breaker. It is important to consult local electrical codes and regulations to ensure compliance with the specific requirements in your area. These codes often specify the minimum breaker size and wire gauge allowed for particular appliances and circuits. Local codes may have additional safety requirements or restrictions that must be followed. When replacing the breaker, it is essential to use a breaker of the correct type and rating. A double pole breaker is required for a 240 volt circuit because it protects both legs of the circuit. Make sure the new breaker is compatible with the electrical panel and has the same voltage and amperage rating as the one being replaced. The wiring, specifically the 10/2 Romex cable currently in use, also needs to be evaluated to ensure it is adequately sized for the new 30 amp breaker. The National Electrical Code or NEC provides guidelines for determining the appropriate wire gauge for various amperage ratings. According to the NEC, the ampacity of a conductor refers to its current carrying capacity, which is the maximum amount of current in amps a conductor can carry continuously under specified conditions of use without exceeding its temperature rating. The ampacity of a conductor is determined by several factors, including the conductor material, size, insulation type, and installation method. The NEC provides tables that list the ampacities of various conductors based on these factors. These tables are essential for selecting the appropriate wire gauge for a given circuit. For example, NEC Table 310.15b16 lists the allowable ampacities of insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in free air based on the conductor size. This table shows that a number 12 American wire gauge or AWG copper conductor with THHN insulation has an ampacity of 30 amps at 90 degrees Celsius. However, it is important to note that the actual ampacity of a conductor may be lower than the value listed in the NEC table if the conductor is installed in certain conditions, such as in a conduit with other conductors or in an area with high ambient temperatures. In these cases, directing factors must be applied to the ampacity to account for the reduced heat dissipation. When selecting a wire gauge for a circuit, it is essential to consider the continuous load and any applicable directing factors. The NEC requires that the wire gauge be sized so that its ampacity is at least 125% of the continuous load. This ensures that the conductor can safely carry the continuous load without overheating. For example, If a circuit has a continuous load of 20 amps, the wire gauge must be sized so that its ampacity is at least 25 amps, 20 amps times 1.25. The NEC also specifies the maximum overcurrent protection device or breaker size for various wire gauges. The overcurrent protection device is designed to protect the conductor from overloads and short circuits. The NEC requires that the overcurrent protection device be sized no larger than the ampacity of the conductor. For example, a number 12 AWG copper conductor with THHN insulation has an ampacity of 30 amps. Therefore, the maximum overcurrent protection device for this conductor is a 30 amp breaker. In general, number 14 AWG copper wire is typically rated for 15 amps. Number 12 AWG copper wire is typically rated for 20 amps, and number 10 AWG copper wire is typically rated for 30 amps. Romex cable, also known as non-metallic or NM cable, is commonly used in residential wiring. The ampacity of Romex cable is typically lower than that of individual conductors because the cable contains multiple conductors bundled together, which reduces heat dissipation. For a 30 amp breaker, number 10 AWG copper wire is generally required. However, it is essential to consult the NEC and local electrical codes to verify the specific requirements for your installation. Number 10/2 Romex cable contains 2 current carrying conductors and a ground wire. It is typically rated for 30 amps when used in accordance with the NEC and local electrical codes. If the existing 10/2 Romex cable is not rated for 30 amps or if it is damaged or deteriorated, it must be replaced with a cable of the appropriate size and type. The cable should be inspected for any signs of damage such as cuts, abrasions, or discoloration. If any damage is found, the cable must be replaced. When replacing the cable, be sure to follow all applicable electrical codes and safety precautions. Disconnect the power to the circuit before working on the wiring. Use properly insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. Replacing the breaker and wiring is a relatively straightforward task, but it is important to do it correctly to ensure the safety of your home and family. If you have any questions or concerns, consult with a qualified electrician. Remember that working with electricity can be dangerous, and it is essential to take all necessary safety precautions. By following these steps and consulting with qualified professionals when needed, you can ensure that your electrical system is safe and up to code. This will protect your home and family from potential electrical hazards. Always prioritize safety and adhere to electrical codes and regulations to ensure a safe and reliable electrical system. By doing so, you can prevent electrical fires, shocks, and other hazards. If the existing wiring is aluminum, different considerations apply. Aluminum wire has a lower ampacity than copper wire, meaning it can carry less current for the same wire gauge. Aluminum wiring also expands and contracts more than copper wiring, which can lead to loose connections and potential fire hazards. If the existing wiring is aluminum, it is recommended to have it evaluated by a qualified electrician. The electrician can determine if the wiring is safe and adequate for the new 30 amp breaker. If the aluminum wiring is not adequate, it may need to be replaced with copper wiring or properly pigtailed with copper connectors. Pigtailing involves connecting a short length of copper wire to the aluminum wire using a special connector that is designed for joining dissimilar metals. This helps to prevent corrosion and ensures a safe and reliable connection. It is important to use the correct type of connector for pigtailing aluminum wire to copper wire. These connectors are typically filled with an antioxidant compound that helps to prevent corrosion. Never use standard wire connectors for joining aluminum wire to copper wire, as this can lead to corrosion and fire hazards. In addition to replacing the breaker and wiring, it is also important to ensure that the electrical panel is in good condition. The electrical panel is the central distribution point for electricity in your home. It contains the main breaker, which controls the power to the entire house, as well as individual breakers for each circuit. If the electrical panel is old, damaged, or overloaded, it may need to be replaced. Signs of an overloaded electrical panel include frequent breaker trips, flickering lights, and warm or discolored breakers. If you notice any of these signs, it is important to have the electrical panel inspected by a qualified electrician. Replacing an electrical panel is a complex and potentially dangerous task. It is always best to hire a qualified electrician to perform this work. The electrician will ensure that the new panel is properly sized for your home's electrical needs and that it is installed in accordance with all applicable electrical codes. Before starting any electrical work, it is important to disconnect the power to the circuit at the main breaker. This will prevent you from getting shocked. Use a voltage tester to verify that the power is off before touching any wires. Wear rubber gloves and safety glasses to protect yourself from electrical shock and arc flash. Arc flash is a dangerous electrical explosion that can occur when working with high voltage electricity. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. Electrical work can be dangerous, and it is important to take all necessary safety precautions. Remember to always consult the NEC and local electrical codes to ensure that your electrical work is up to code. The NEC is a comprehensive set of electrical safety standards that is updated every 3 years. Local electrical codes may have additional requirements that are not covered in the NEC. By following the NEC and local electrical codes, you can ensure that your electrical system is safe and reliable. Replacing a breaker and wiring is a relatively straightforward task, but it is important to do it correctly to ensure the safety of your home and family. If you have any questions or concerns, consult with a qualified electrician. Remember that working with electricity can be dangerous, and it is essential to take all necessary safety precautions. When working with electrical systems, accuracy and attention to detail are paramount. Small errors in calculation or installation can have significant consequences, potentially leading to electrical hazards or system malfunctions. Therefore, it is crucial to double-check all calculations and wiring connections to ensure they are correct. The calculation of amperage, as demonstrated earlier, is fundamental to determining the appropriate breaker size and wire gauge. This calculation ensures that the electrical components are adequately protected and that the system operates within safe parameters. In addition to accurate calculations, proper wiring techniques are essential for a safe and reliable electrical system. Wiring connections should be made securely and with the correct type of connectors. Loose or corroded connections can cause resistance, leading to heat buildup and potential fire hazards. Therefore, it is important to use high-quality connectors and to tighten them properly. Furthermore, the wiring should be properly insulated and protected from physical damage. Exposed or damaged wiring can pose a shock hazard and should be repaired or replaced immediately. When working with electrical systems, it is also important to be aware of the potential for arc flash. Arc flash is a dangerous electrical explosion that can occur when working with high-voltage electricity. It can cause severe burns, blindness, and even death. To protect yourself from arc flash, it is important to wear appropriate personal protective equipment such as safety glasses, gloves, and flame-resistant clothing. It is also important to energize the circuit before working on it whenever possible. In addition to following safe work practices, it is also important to maintain your electrical system properly. This includes regularly inspecting the wiring, breakers, and other components for signs of damage or wear. It also includes testing the breakers periodically to ensure they are functioning properly. By maintaining your electrical system, you can prevent potential problems and ensure that it operates safely and reliably for many years to come. If you are unsure about any aspect of electrical work, it is always best to consult with a qualified electrician. An electrician can assess your electrical system, identify any potential hazards, and recommend appropriate solutions. Hiring a qualified electrician is an investment in the safety and reliability of your electrical system. They have the knowledge, skills, and experience to ensure that your electrical work is done correctly and safely. Remember that electrical work can be dangerous, and it is important to take all necessary precautions. By following safe work practices, maintaining your electrical system, and consulting with qualified professionals when needed, you can ensure the safety of your home and family. Always prioritize safety and adhere to electrical codes and regulations to ensure a safe and reliable electrical system. By doing so, you can prevent electrical fires, shocks, and other hazards. These principles should guide electrical installations, repairs, and maintenance. The integrity of the electrical system is critical for safety and property protection. Periodic inspections by qualified electricians are recommended, especially in older homes or those with known electrical issues. These inspections can uncover hidden problems and ensure that the electrical system meets current safety standards. Ignoring electrical problems can lead to serious consequences, including fires and electrical shocks. Therefore, it is essential to address any electrical issues promptly and professionally. When making electrical modifications or additions, it is important to consider the overall capacity of the electrical system. Adding too many circuits or appliances to an overloaded system can create a dangerous situation. A load calculation should be performed to determine the total electrical demand of the home and ensure that the service entrance and electrical panel are adequately sized. Upgrading the service entrance or electrical panel may be necessary to accommodate increased electrical demand. This is a complex task that should be performed by a qualified electrician. Furthermore, it is important to keep electrical panels and equipment clear of obstructions. Access to electrical panels should be maintained for safety and maintenance purposes. Storing items in front of electrical panels can impede access and delay emergency response in the event of an electrical problem. Finally, it is important to educate yourself and your family about electrical safety. Teach children about the dangers of electricity and how to avoid electrical hazards. Make sure everyone in the home knows how to shut off the power in case of an emergency. By promoting electrical safety awareness, you can create a safer environment for yourself and your family.